Alright, in today's video what I'm going to do is I'm going to go through some practice problems for calculus. Okay, so what I'm going to do is I'm going to determine the derivative of each function. I'm looking at number 16 of this review package. So f of t equals 0.5x e to the x. Now there's a few things that you're going to have to remember. You're going to have to remember the product rule. Okay, so y equals uv, which means the derivative is going to be u prime v plus v prime u. The quotient rule, u over v, which means we've got v u prime minus u v prime all over v squared. You're also going to have to remember the derivative of an exponential function. So the derivative of an exponential function, let's say b to the x, is just going to be the function copied down multiplied by ln of b multiplied by the derivative of the exponent. In this case it's 1. So basically this is the derivative of b to the x ln b. If I want to introduce a more complicated function, then it's going to be the same format: copy down the exponential, ln b, then g prime of x. You'll also have to remember sine of x's derivative, which is cos, and you'll also have to remember cos's derivative, which is negative sine. These are important functions and derivatives that you have to remember. So in this case, I've got a constant out in front. I can kind of leave that alone. And I'm going to call this guy u, and I'm going to call this guy v. Well, u prime is just going to be 1, and v prime is going to be e to the x ln e times 1, which is the derivative of x, which you don't really need. You also will note that ln e itself is 1. So I've got e to the x times 1 times 1, so the derivative of e to the x is itself. That's something we learned in the note. So I've got u prime v prime. It looks like this is a product rule, so I'll be using this. So f of t is going to be 0.5 times u prime times v plus v prime times u. And what I'll end up getting is 0.5, and I'll get e to the x plus x e to the x. Notice how I've put x in front of e to the x? That's just by convention. I just like having x in front. Okay? So what do I get? Well, I can factor out e to the x. And what I'll get is 1 plus x inside the bracket. Now what's neat about this is that if I want to find the derivative, simplify my answer, I'm pretty much done. All you have to do is literally factor out a common factor and see if you can clean up what's left inside the square bracket. I can't really clean this up, so I'm pretty much done. That's it. That's 16a. Let's do 16e. Better yet, let's do 16c and e. Let's do that. So 16c. What do I have? I have f of x equals 3x squared plus 5x minus 1 all over e to the x. So I'm going to call this thing on the top u, and I'm going to call this thing on the bottom v. And what I'm going to do is I'm going to apply the rule. This time, the rule I'm going to apply is quotient rule. So I need u prime, 6x plus 5, and I need v prime, and we already know what the derivative of e to the x is. We found it in the previous example. It's itself. And that's a very special function, okay? And that's only e to the x. If it were e to the x squared plus x in the exponent, that's totally different because you have to take the derivative of the exponent. But e to the x is a special case. Only e to the x is its derivative is itself, only in that case. So now let's apply the derivative rule. So f prime of x is going to be v times u prime minus u times v prime all over v squared. I can take out a common factor on the numerator of e to the x. So I get e to the x, square bracket, 6x plus 5 minus 3x squared minus 5x plus 1. And I can clean up the top. Now, if you notice, not only can I clean out the top, but there is a canceling that I can do. I can cancel one factor of e to the x on the top with one factor of e to the x on the bottom. Once more is, on the numerator, I can collect 6x and negative 5x. I can also collect positive 5 and positive 1. I get 1x minus 3x squared plus 6 all over e to the x. That's it. That's basically what I get. So that's 16c. Let's do 16e. F of x equals sine x e to the cos x. Okay, now this is also a product rule, but this is made up of a trig and an exponential trig combo. So u prime is going to be cos x, v prime is going to be e to the cos x. Remember, I copy down the exponential, take ln of the base, and then take the derivative of the exponent. I get, that's 1, I get negative sine x e to the cos x, and I apply the product rule. Well, f prime of x is going to be u prime times v plus v prime times u. And what do I get here? Well, I have a common factor of e to the cos x. It seems like I'm always going to have a common factor of some exponential term, at the very least. What do I get left? Cos x minus sine squared x. If you notice, there are two sines. When they multiply together, I get sine squared. That's basically what I get for the derivative. I can't really do much more than that. So that's 16e. While we're at it, let's do 16f. Why not? So what do I get? F of t equals 1.5 t 3 to the sine of 0.1 t squared. Well, I can leave the 1.5 alone. I'm going to call this u, and I'm going to call this v. So u prime is going to be 1, and v prime is going to be the exponential copied down, multiplied by ln of the base, multiplied by the derivative of the exponent. Now the derivative of the exponent means I have to go outside inside. I have to go cosine, that's the derivative of the outside, multiplied by the derivative of the inside, which is 0.2t, because the 2 drops down, right? And I can clean this up a bit. I can multiply out ln 3 with 0.2. I'll get some funky decimal, but for now, I'll just leave it as 0.2 times ln 3t. and I'm just noting that t is not inside the ln. That's why I put this bracket here. Times cos of 0.1 t squared, and then at the end I'm going to throw in that exponential. This is just by convention. This is what we do. We put the exponential term at the end and everything else starting with the constants at the left. So there you go. So now we apply the product rule. So f prime of t is going to be 1.5, don't forget about that, equals to u prime times v. Here, why don't I just put a dot? Plus v prime, which is this monstrosity, cos of 0.1 t squared 3 to the sine of blah blah blah. And then we're also going to have u, which is t. So I can actually combine these two terms and rewrite it as t squared. And I get that singular term. And I can factor out the exponential because that is my common factor. If you notice, this and this are common. So I can take it out and I get 1.5 times 3 sine of 0.1 t squared bracket, and what do I get on the inside? 1 plus 0.2 times ln 3 times t squared times cos of 0.1 t squared. That's it. And notice that I'm not going to multiply 1.5 and 3 together. See this exponent right there? Sine of 0.1 t squared? That tells me that that 3 is belonging to that exponent and that 1.5 is completely outside of it and cannot combine with the 3. Okay? So that 1.5 is a coefficient, whereas 3 is the base. So there you go, that's 16F. Let's do 17, and we'll do 17 A and C. (17a). Okay, so for 17a, f of x equals 5 e to the x minus e2 to the x. Okay, well, the derivative of e to the x is equal to e to the x. And notice how this isn't like a product rule at all. It's a subtraction of two functions, so we don't have to worry about doing a product rule. And the derivative of e to the 2x is e to the 2x ln e, which is 1, times 2, because that's the derivative of the exponent. So I'm just going to put 2 out in front. That's basically the derivative, guys. Now, how do I solve for the maximum and minimum values? Well, I'm finding the CPs. Okay, the CPs mean I make the derivative equal to 0. And I try to solve this equation, which means I got to do some algebra. Okay, now I move one term to the other side. And then I can divide one number by the other. So in this case, I could cancel out 5. Really doesn't matter, but yeah. 2 divided by 5 is 0.4. So I get 0.4 e to the 2x equals e to the x. Then what I have to do is I have to make sure that all the bases are the same. This base is 0.4. This is base e, and so is this. So that's a check, check. So I have to convert this guy to a base e. So I just rewrite it as e to the log base e of 0.4. Now log base e is just the ln that we were talking about. So e to the ln 0.4 is the same thing as saying 0.4. I can combine these two terms by adding the exponents, because notice this is a multiplication of two powers. So get e to the ln 0.4 plus 2x equals e to the x, and then I just cancel out the bases, and I get my equation. Ln of 0.4 plus 2x equals to x, and then I can isolate. So I will move x over, and I'll move ln over. What I'll end up getting is 2x minus x equals negative ln 0.4. 2x minus 1x is just x. So basically x will be this term. Now I'm not sure if the answer is presented as a decimal or as an exact solution, but this is the solution, and if they want the decimal, you just punch that into your calculator. Okay, so that's that. That was 17a. Oh, actually, no. They want the maximum and minimum values of each function. What that means is they need the y's. Okay, so I found the x. So to get the y, all you do is take that x and you plug it back in to f of x. I'm not going to do that here just because I don't have a calculator handy. You're going to take that x value and you're going to plug it back into this function. And that's it. Okay. 17 C. What does 17C look like? Similar process. Why don't I just go with 17B then? That looks a little different. So g of x equals 3x minus 4, x plus 1, all over e to the x. Now, if you notice, on the top, you have a quadratic. On the bottom, you have an exponential. Why don't I just expand by FOIL the top to make it nicer to take the derivative of, rather than having to do a product rule on top? So I get 3x squared, okay, if I do FOIL, plus 3x minus 4x, that's negative x minus 4, all over e to the x. So this is the expansion of that, okay? Now, I'm going to call the top u, and I'm going to call the bottom v, and I'm going to do the derivative. U prime equals 6x minus 1, v prime equals e to the x. It equals itself. Now all I'm going to do is I'm going to plug it into the derivative rule, the quotient rule. So v prime is, I'm doing v times u prime minus u times v prime. And if you notice, there is all over v squared. There is a common factor on top. You get e to the x. And then if you try to collect like terms, you can simplify things quite a bit. So what do you get? Well, you get the e to the x canceling, at least one factor. And inside the red bracket, you get 6x plus x, that's 7x, minus 3x squared, and then plus 3, all over e to the x. Now this, again, is the derivative. If we want the maximum or minimum values, we have to set the derivative to 0. This is also a fraction, which means we have to make the numerator 0. 7x minus 3x squared plus 3 equals 0. And we have to solve this equation. We can rearrange it to say 3x squared minus 7x minus 3, and we would have to factor this expression. Two numbers that multiply to 9, okay, but add to multiply to negative 9, but add to negative 7. Is that even possible? Not really, okay? So it's not really possible to solve. So what we end up getting is something that is impossible, Okay, so no CPs, which means no max or min. Let me just double check that, because that seems a little weird that would happen here. I must have screwed up the expansion. 3x minus 4x negative x, that looks good. And yes, the expansion looks great. The derivative looks great. And expanding in looks great. So that looks fine. And it seems like it didn't work. Okay, so what we could do, actually, since factoring didn't work, we could try the quadratic formula. So you'd have to go x equals 7 plus or minus square root of 49 minus 4 times 3 times negative 3. That looks like it will work, divided by 2 times 3. Anyways, once you solve for the two x values, you take each x value and you plug it into the y values, and you will get the maximum and or minimum values of the function. So there you go. That is 17C. All right, for 18, the concentration of a particular medication in a patient's bloodstream can be modeled by that function. Determine the maximum concentration of this medication in a patient's bloodstream. Well, you do the same thing. In number 18, you take this guy, you find its derivative, and that's it. That's basically it. You set it to 0 and you solve for your function. Well, u on top, v on the bottom, I can split it up. U prime is 24t cubed. V prime is equal to e to the t plus 2 ln e, which is 1 times 1, so that's v prime as well. And then I can just apply my derivative rules. So c prime of t equals to v times u prime minus u times v prime. I will have to take out a common factor on the top. If you notice, it's a similar format to the last example, last few examples actually. Basically, a factor of the top can cancel with a factor on the bottom, leaving me with one factor on the bottom. So that cancels with that. And then I've got a common factor on top, an additional common factor. I can actually take out 6, t cubed, right, out of the square bracket. So I get 4t minus, no, I get 4 minus t. I'm going to do the same thing. I'm going to set the derivative to 0 and solve for t, which means I'm just making the numerator 0. So I've got two options, t equals 0 or t equals 4. I take those t's and I plug it back in to the original expression. If I plug in t equals 0, my concentration is going to be 0. Okay, so that's probably not the max. The max probably occurs at t equals 4. So if I plug in 4, whatever this is, 6 times 4 to the 4 over e to the 6, whatever that is, that's probably the max, and I want you to make sure that you put the right units. Okay? Number 19. The function n of d equals blah models the number of bacteria that are infected with the disease. Determine when the maximum. So notice the language. It doesn't say determine the max. It says determine when the max were infected. So it means find d. So here, but we do the same process. Okay, n of d equals 90d times e to the negative 0.4d. I take this, take the derivative, set it to 0, solve for d, and actually I would be finished when I finish solving for d. So I'm going to forget about the 90. I'm going to call that u. I'm going to call that v. U prime is equal to 1. V prime is equal to e to the negative 0.4 times negative 0.4. Ln e is just 1, so I'm just going to forget about that. So anyways, it can be rewritten like this. Okay, and I've got v prime now. So all I'm going to do is apply, in this case, the product rule. So I get u prime times v plus v prime times u. I'm going to factor out the exponential, and I end up getting 1 minus 0.4d, and I can solve for d in this case. Notice the exponential, okay, if you notice with any exponential, it will never actually hit 0. It'll never actually hit the x-axis. What that means is that this term can never be equal to 0. So all I have to worry about for finding max and min are the other terms that aren't exponential. So I go 1 minus 0.4d equals 0, and I solve for d. d is going to be 1 over 0.4. So whatever that is in number of days, that's your answer. Okay? Determine the maximum min values of each function. Okay, so what I'm going to do here is I'm going to do part C, because I haven't really done anything like that before. So this is 20 now. So this is, oops, this is 20C. W of x equals 2.5 e to the x minus 1, 3x squared plus 2x minus 5. So I'm going to call this guy u. I'm going to call that v. If you notice, like, if you have e to the x and there's no coefficient in front of x, and it's not like x squared, it's just x, the derivative is going to be itself. Okay, so remember that as a cardinal rule. V prime is going to be 6x plus 2, and I can apply my product rule. W prime of x equals 2.5 bracket u prime times v plus v prime 6x plus 2 times u. Common factor is e to the x minus 1. I get 3x squared plus 2x minus 5 plus 6x plus 2. And I end up getting e to the x minus 1 bracket. I get 3x squared plus 8x minus 3. Now this is factorable, I believe. This won't go to 0. So forget that. This can go to 0. How do we solve this? Let's see, can we guess? 3x x minus 3, no, plus 3 minus 1. Does that work? 9x minus x, yep, that works. Equals 0, so my two factors are x equals 1 over 3, or x equals negative 3. So all I do is take these x values and I plug it in to the original function. So whatever you get there are your answers. Okay? So that is 20C. I think I'm going to stop there for now. Just because the rest of it is a lot simpler and I could use a little bit of a break here. So I did about 4 or 5 questions. We'll get you in the next video. So I'll see you guys later, and peace out.